You're now watching live feed from Wenchang Satellite Launch Center. China's Chang'e 6 mission blasts off into the sky. It's all systems go, Professor Yang.
So magnificent. And now the path is clear.
It's now starting its epic journey to the moon.
So at the moment, 17 seconds after liftoff will be the pitch over, change the direction.
Right.
And now you can see this is a video captured by the camera mounted on the launch vehicle. Actually speaking, on the core stage, you can see two of the rocket boosters.
Right. Are the cameras infrared?
This is a visible light camera.
Invisible light camera.
Yep. And you can see the flames of the boosters.
Yeah.
Each have two rocket engines, YF-100 rocket engines with a thrust more than 120 tons.
Sure.
And the booster will work for nearly 3 minutes.
3 minutes. And then it will detach from
We can
rocket.
hear from the ground station, the voice comes from the reporters of the ground station. They
Right.
mentioned that the telemetry received normally and the spacecraft fly normally.
Now, as we mentioned, this mission will last for 53 days, much longer than the previous mission,
Exactly.
the Chang'e 5. It's going to make a soft landing on the far side of the moon, somewhere around the Aitken Basin, and then it's going to bring back lunar samples from the
So
moon.
next step will be the separation of the side boosters.
Yeah.
We have 4 boosters within
And-
several seconds.
As we were discussing, Professor Yang, how long would it take for the probe to actually land on the moon?
Well, the powered descent only lasts for several minutes, less than 10 minutes. But they will wait for this moment on the circumlunar orbit for several days.
Yeah.
So that depends on the design of the whole mission profile. Next, we'll be seeing the separation of the booster soon.
Now, even the launch moment was successful. We couldn't say that this entire mission is a success because every step of the way will be pivotal
Yeah.
for the entire mission. There's complicated procedures involved, and we're going to bring you all the details in our live coverage. What will be the moment that marks the success of the launch phase of this mission?
Yes.
Which
And,
part?
the separation of the probe with the end stage of the launch vehicle, and also that's the unfolding of the solar panels.
Solar panels.
Okay, great, beautiful.
Boosters?
Yes, all the 4 side boosters separated normally.
Applause from the control center, and that's certainly another step forward.
Yes. So the rocket will continue to work several minutes. So and the next critical step will be the separation of the payload fairing,
Right.
because that it's in an ascending phase and its altitude is begin go higher and higher. So at a certain moment we do not need the payload fairing to protect the probe.
Right. We are now a little over 4 minutes into this mission, and it looks like so far so good.
So now it's a flying of the first stage. So as I mentioned, the first stage have 2 rocket engines with liquid hydrogen and liquid oxygen as a propellant, and each of the this is a 3D animation.
3D animation,
Yeah,
and
and
back
this
to
is a
the
video
cameras
from the camera,
installed.
yeah.
Right.
And you can see this is now today, at this moment we can see the fuselage of the first stage. And as I mentioned, we have 2 rocket engines on the first stage of the YF-77 rocket engine. Each have a thrust of more than 50 tons. And we just heard voice, that's the ground station, the radar tracking the spacecraft very normally.
And approximately how high is it? How far away is it now from Earth? Because we can now see that beautiful view of
yes,
Earth.
we were actually speaking, it's already, I believe it's already more than 50 kilometers high. And when it is high enough, as I mentioned, we will conduct the separation of the payload fairing. Oh, you can already see on the left our screen, we can see the camera inside the payload fairing. We've already seen the scene inside the payload fairing.
Right. That's of course giving us a very clear look, a very clear vision of the payload from inside the probe.
Yeah, inside the payload fairing. So we can see that the Chang'e 6 probe is stored in this payload fairing.
Right.
And the next video, okay, great,
It's
beautiful.
opening up.
Separated.
Separated.
So we don't need the, as I mentioned, because it's already high enough, we don't need the protection of the 2 pairs of payload fairing. So it's already in outer space.
So next phase will be the second stage ignition.
First, we should separate the first stage.
First stage, right?
Yeah. Just about 8 minutes after the liftoff will be the first shutdown of the first stage. Sorry, the separation of the first stage.
Separation of the first stage followed by the second stage ignition.
Ignition,
Right. Wow.
So this is the 3D animation. This is a video from the board on the rocket. Now you can see the beautiful Earth and the curve of the horizon of the Earth.
It really looks like, I know it is a technically demanding and challenging mission, but it's also a very romantic and beautiful journey.
Yeah, what
to
you
the
see
moon.
now is just above the Pacific Ocean.
Right. This mission is going to last for 53 days, and it consists of 11 phases. Every detail, every single action could have an effect on the entire mission.
Every step, as you mentioned, every step is important. Every step is critical. So although the thrust of the core stage, as I mentioned, of the first stage is much smaller than its 4 boosters, but it will work longer because the liquid hydrogen has higher energy. Great, the flight is normal according to the voice reported by ground stations.
Right. So correct me if I'm wrong, Professor. The spacecraft consists of 4 separate components.
Exactly.
There's an orbiter, lander, ascender, and the re-entry module. And
Exactly.
after launch, the Chang'e 6 will travel to the moon and enter lunar orbit, and the lander and the ascender will travel to the surface.
Yes.
While the orbiter and re-entry module stay in orbit,
The combination of the orbiter and the returner will stay in the lunar orbit to wait for the ascender.
and the ascender and the lander will touch down at the
collect
far side of the moon and
samples.
collect samples to the re-entry module.
No, to the ascender. So they get the samples in the container. Okay, great. The first stage has separated.
First stage separation.
And now will be the ignition of the second stage.
So my understanding is that the ascender will blast back into lunar orbit and transfer the sample to
Exactly.
the re-entry
Yeah,
module.
look, you can see that we can see this is a camera mounted on the second stage. We can
Right.
see the first stage separated and going far behind the second stage.
Another view from
So
the,
this
I
is the
think that's
view
the
of the.
payload.
We can see that there is also a camera mounted near the rocket engines. So we can see the working of the rocket engines. So on the right of the screen, we can see the video camera mounted on the rear part of our second stage. So we can monitor the working of the rocket engines. This rocket engine is called YF-75D. So it is also use liquid hydrogen and liquid oxygen as a propellant. If you work much longer, although the thrust is much smaller than the first stage. But it is very unique because it will ignite twice. So with the first ignition, it will burn several minutes. So at the moment, about more than 10 minutes after launch, it will shut down first. So at this moment, it will enter what we call the parking orbit, and it will float in this parking orbit for about 10 minutes, which causes a coast phase.
And once it enters orbit, well, before it touches down on the moon and after it goes into orbit, one very important step is to slow down the probe just to make sure it makes a soft landing.
Exactly.
On the moon.
So you know that there are two steps. The first is what we call the lunar orbit insertion, which means that we slow down the vehicle from the translunar orbit to the circumlunar orbit, and then we, with what I mentioned, as you mentioned, the combination of the lander and ascender, with the combination of these two spacecraft, we use the propulsion system to slow down the vehicle from about 1700 meters per second to zero. Also, the altitude from about 100 kilometers to zero within only 10 minutes. So this is also another critical step.
Fascinating. And another highlight of the mission is that there's this relay satellite.
Yes,
the Chieqiao 2 in Mandarin and Magpie Bridge 2 in English. So simply put, there is no direct line of sight from the Earth to the far side of the moon.
Absolutely.
And that's why we need that relay satellite to learn more about what's going on there and also receive data.
Well,
from
you know,
the
as you mentioned, the Magpie Bridge 2 or the Chieqiao 2 data relay satellite. But I should emphasize that Chieqiao 2 is an extremely important part for our sample return mission from the far side of the moon. We cannot see the our probe, the lander on the lunar surface with our ground stations. And not only, you know, that this time the Chieqiao 2 or the Magpie Bridge 2 not only acts as a bridge to conduct the communication, but also it is very important for us to measure the precise position and velocity of the lander, the coordinate of the landing point, and also during the ascending phase of the ascender. You know that the basic requirement for rendezvous and docking is that we must ensure the ascender entered an orbit with the same orbital plane of the orbiter.
Sure.
So that's really important.
So does the Magpie Bridge providing data or visual images from the far side?
Okay, we can see, we hear the voice of the ground commander that the second stage has already shut down for the first time. Now the whole combination of the rocket and our probe has entered the coast phase. So it will last about 10 more minutes.
10 more minutes.
You know that for any probe to the moon, we must have or conduct the translunar orbit insertion near the equator. But you know, although you know that Hainan province is the most southern province of China, but still it's not located on the equator. So that is the reason why we need a coast phase. So when the first shutdown of the second stage completed, we will have a coast phase about 10 more minutes, and then we ignite again near the equator, and then it will be the translunar orbit insertion. We can just wait.
So again, the Magpie Bridge 2, does it provide data or visual images of how the probe is there retrieving samples from the Aitken Basin?
Actually speaking, the camera mounted on the lander will monitor the whole sampling procedure, and then the signals of these videos will transfer first to our Magpie Bridge 2 data relay satellite, and then forward it to the Earth.
Is there a time delay, I would imagine?
The time delay is only 1 more second.
One more,
you
a
can
little more than a second?
Yeah, because you know that it's too far from the Earth. The distance is more than 380,000 kilometers away.
What if the command center gives some orders to the probe? Does the Magpie Bridge 2 also do the job?
Exactly. So we cannot directly send the command to the probe, to the lander directly. We can only first send the command to the Magpie Bridge 2 and then forward that to the lander. So now we can still, you know, that at this moment we still have the communication with the spacecraft with the help of our Tianlian data relay satellite. So you can see we can still send the video captured by the camera mounted on the second stage. So this is a 3D animation, but it is based on the real data we get from the parameters measured by the sensors on board our spacecraft. So it's just a fly above the Pacific Ocean. So when it reaches the equator, it will ignite again.
Yeah. Before we get to the technical details of this mission, Professor Yang, let's talk about the different types of landing or different types of lunar exploration. Because there are the flybys, there's the hard landings, and then there's the soft landing. I remember there's one more type. Which part is most technically challenging?
Absolutely, the sample return will be the most challenging one, like this one. You know that, as we discussed before, China had already conducted 3 phases of the lunar exploration program in 3 very simple Chinese words. Rao, Luo, Hui. Rao means orbiting in English, and you know that we conducted by the Chang'e 1 probe and the Chang'e 2, and Luo means landing conducted by the Chang'e 3 and Chang'e 4, and Hui means sample return. So we conducted with the Chang'e 5. So you see, for each one step, we also need to do the things on the previous step. For instance, if you want to conduct a landing, you must have the orbiting, and for the sample return, you must first have the orbiting and then the landing.
Yeah, it's always a follow-up mission of the previous one.
So we master the key technologies one by one.
So China's lunar exploration mission, what is the final aim of this entire mission?
Well, you know that today we are already in the 4th phase of our lunar exploration program. So for this program, we will set up or build a permanent base on the lunar surface called the International Lunar Research Station. So it is an international cooperation with other countries. So spaceship is more than 26 tons. So you can see it's even only not included the lander, even the spaceship itself is between the rocket and the probe.
Right.
The lunar surface. I enjoy this, and also the dash lines is the communication links between the ground station. Okay, beautiful.
And that was the separation.
So
of
now
the
you
rocket
can see the video is the rear part of the Chang'e 6. Actually speaking, is the orbiter. So we can see the cylindrical part of the probe is the biggest part is the orbiter.
So this certainly marks another important step in this mission. That's the separation of the rocket and
so,
the
so this is also another critical step. And then will be the unfolding of the solar panels. Both on the orbiter and on the lander, because they will fly independently several days later. So we need the unfolding of the 2 pairs of solar panels.
And until these 2 sets of solar panels are opened up, that will mark the success of the launch mission.
Exactly. Moreover, we should also evaluate the accuracy of its initial orbit, because you know that only it is accurate enough, we can have the probability to conduct the successive procedures.
And I also want to talk about China's space station, the Tiangong. What kind of international cooperation is being showcased on the CSS?
I believe that our Tiangong space station is a very ideal place to conduct the international cooperation. So today we already have the joint experiments with other countries. And next step, we already talked many times, will be the visiting of the foreign astronaut to our Tiangong space station. So
you know what, Professor Yang, when I say the scientists, engineers taking out their glasses, it means that they are really...
Okay, we just heard voice that, as I mentioned, the optical parameters has already been acquired. So, as I mentioned, the accuracy of the optical parameters is also very critical for our mission.
Sure. Has the spacecraft established communications with the Magpie Bridge 2 at this moment?
No, at this moment it's still too far from the Magpie Bridge 2. So at this moment it still have the communication link between the Tianlian database satellite or with space tracking ships, such as Yuanwang series tracking ships on the Pacific Ocean. They are already in SMILE, so that means that the most risky part has already passed for the launch.
And they start talking and having some small chat over there.
Yeah.
It's a rewarding moment for the scientists.
Yeah, so I believe that we can see the big red screen soon.
Yeah.
It's our tradition.
Yeah, it is. It really is something that we are all looking forward to.
Yeah. Now you can see it's already more than half an hour now. So that is a very important feature for the launch of the Long March 5 or the Long March 3 A series,
Right.
because we need a coaster phase that lasts very long.
And now let's hear some more insights from Mark McCorin, former Senior Advisor for Science and Exploration at the European Space Agency in the Netherlands. Thank you so much for joining us on our program. Now, as we're both waiting for that big moment, the announcement of the success of the launch mission, what aspect of Chang'e 6 lunar mission are you most looking forward to?
Well, as a scientist, it's an amazing thing to be able to go to the far side of the moon and bring samples back. It's very different from the near side of the moon, the piece of the moon we see all the time because of the way the moon is locked to the rotation of the Earth. It also will hopefully bring us some idea about the way that the moon was struck by these very large impactors, by asteroids, early in the solar system history, billions of years ago. Was that something that happened very quickly in one big bunch of impacts, or was that something that happened slowly? And by returning samples from that particular location, the South Pole Aitken Basin, we should actually be able to learn much more about the history of our solar system that way. So that's really exciting. But let me also say, congratulations, of course, to getting to this point now. Half an hour into the mission, it seems to be going extremely well.
And as I mentioned, it really is a very important mission for us to understand the formation, the evolution of the moon over a span of billions of years. And China, as we know, is also carrying international payload in this mission. It's been advocating international cooperation in space for a long time. What do you make of the cooperation between China and Europe, Mark?
Well, I think it's a good thing. I've been talking to some of my colleagues this morning, ESA colleagues who are out there in China at the launch, and hopefully I'll chat to them a little bit later on, and hopefully they will have seen that very, very beautifully as we did on the live stream. But bringing those instruments on board to do science, of course, is the main goal of this kind of cooperation, is to share the scientific knowledge. And this is something where, of course, we collaborate internationally. We collaborate with the United States, we collaborate with Russia, we collaborate with Japan, and we collaborate with China. We also have a mission which should be launched in the next year or so called SMILE, which is a collaboration between China and ESA, where that mission will be investigating the magnetic field of the Earth. And that's an important aspect which is linked to so-called space weather, where the impact of the sun on the Earth's atmosphere is something we want to study in more detail. So we just saw the launch contract for that was signed last week. That will be a European launcher with a European Chinese payload. And what we just saw today is European parts on a Chinese-led mission to the moon. So I think that this scientific collaboration is, of course, very important. We should always keep in mind that space is a very political environment, of course, and there are all sorts of geopolitical issues in the background here. But as a scientist, I'm very happy to see this collaboration go forward.
Mark, let me also ask you this. I could see Chinese calligraphy hanging on the wall, and I'm pretty sure that you're familiar with the Chinese culture as well. And you must also know that the Chang'e is named after this legendary Chinese moon goddess. Do you also share this dream of lunar exploration, this passion, and of course renewed ambition to explore the moon?
I think it's something, of course, that's fascinated me throughout my life. I'm old enough that I was around when the Apollo missions went to the moon, and I've worked with many of the Apollo astronauts. I've been on tour with Buzz Aldrin, for example, who was on that very first mission with Neil Armstrong to the surface of the moon. And to see that come back now in recent years, of course, there is an element partly, again, of this geopolitical aspect, whereas it was the Soviet Union and the United States before. Now you have a much broader array of players in this game. And there's also this question about this exploitation that your guest there spoke about a bit earlier on, which was that exploration is driving the science, but the possibility of looking at the moon as a resource is another thing. I'm a little bit skeptical about making it a fully commercial thing. I'm not sure how that would work. And we do need to think about how we protect the resources as well, that it shouldn't be a free-for-all, that everybody can go and just get rich. The same applies to Mars. We don't know if there's life on Mars yet. Should we be going there with human beings until we've investigated it properly scientifically? So I think it's a very interesting time. I mean, if I'm right, that as you said, the calligraphy behind me is the constellation of Orion, Li Hu Zhuo, if I remember correctly from one of my trips to to China. And so I am also very interested in looking well beyond our own solar system. So I've studied the constellation of Orion for many years in my career, and those dreams are definitely real. And that inspiration that space can bring, and then the collaboration that that also encourages, I think is something we need to reflect back to Earth, collaborating to solve some of the challenges that were addressed earlier in your program, for example, nuclear fusion and how we solve the energy crisis. That we're only going to survive on this planet by international collaboration, and we're not going to go and live on other planets very soon. So I think that's the important strand here, international collaboration for helping this planet. And lunar exploration is an exemplar for that.
Of course, we are seeing competition at different degree, but it doesn't have to be that way. I mean, the discovery, the learning of the moon is certainly bringing benefits to all of humanity. Thank you so much, Mark, for sharing with us your insights. Well, the Chang'e 6 will carry equipment from France, Sweden, Italy, and Pakistan. It's part of China's international cooperation in space. A French instrument mounted on the lander will study the origin and dynamics of the lunar exosphere. CGTN's Natalie Carney talked to Pierre-Yves Meslin, a planetary scientist whose team invented the instrument.
For years, planetary scientist Pierre-Yves has been working on instruments destined for Mars. But the launch of China's Chang'e 6 spacecraft now puts him at the cutting edge of moon exploration. His invention, the detection of outgassing radon, or DORN, is set to become the first ever French instrument to be deployed to the surface of the moon.
The objective of the DORN experiment is to study both the origin and the dynamics of the lunar atmosphere, but also to study the physical and thermal properties of the lunar soil where those gases are produced.
To do this, DORN will measure the radioactive gas radon, which is produced in lunar rocks and, when emitted, migrates to colder areas of the lunar environment.
If we understand better the migration of radon, we will be able to better understand also the migration of other volatile species, like, for instance, water, that can migrate to the cold polar regions and then form ices. That is a prime interest for the future Chang'e 7, Chang'e 8 missions or missions from other international agencies.
Romain Maton is the mechanical architect of the DORN.
So here we have the 8 detectors which are shining. The radon is going to be captured by the detectors, 2 detectors forming a telescope. The front one will see the alpha particles coming from the radon, and the other one will be here to discriminate any other events which will be seen by the instrument.
The project team says time was the biggest challenge when it came to the DORN's development.
The project started early 2020, so it was right before COVID time, and we delivered last summer. So overall it was 3.5 years of development, which is something that is super short for us. So having an instrument that we develop and that is going to the far side of the moon, it's really exciting for us. We are going to be part of a mission that has a really technological fate. So it's a great honor to be part of it.
More than 20 French engineers worked closely with Chinese colleagues at China's Institute of Geology and Geophysics and the Chinese University of Geoscience in Beijing to make the project happen.
This is the first time that France and China are collaborating in the field of solar system exploration. First, they helped us interacting with the engineers from the spacecraft team at CAST. They also helped us negotiate the spacecraft resources that we needed for our instrument. And they also helped us a lot after we delivered the instrument to China last August. They helped us mount the instrument onto the spacecraft. I think we have established a relationship of trust and also friendship between the two sides.
Pierre-Yves is now in China for the launch of the spacecraft and will stay there for a month to monitor the DORN during its time on the far side of the moon. He'll collect its data and continue harnessing the benefits of international collaboration in discovering the wide, vast unknowns of outer space. Natalie Carney for CGTN, Toulouse, France.
Well, international cooperation is certainly a highlight of this mission, and our colleague Mark, right there, he was talking about turning this idea from exploration of the moon to exploitation of the moon. And you rightly pointed out that really we are facing this first mover advantage. For example, whoever gets there first will have a say on how to explore the moon and maybe perhaps making rules for the exploration of the planet.
Well,